Hey study buddies, so today we are going to be looking at the log and exponential form. So let's first take a look at what is the log, and then we're going to go more in depth of this function. So if we take a look, I've graphed our regular exponential function with a base of 2, so y equals 2 to the exponent x. And then I've also graphed our log, so y equals log base 2 x. All right, now how do we know that this is our inverse function? Well, of course, we use a couple of properties to determine if something is an inverse function. You can see right here, it is a clear reflection in the y equals x axis, so we know for sure that this is going to be an inverse of the function. Also, if you take any given point, you can see the x and y coordinates are switched. And finally, you can see that their domain and ranges are switched. So we're not going to go into too much detail about that. Just know that log is the inverse of the exponential function. So let's take a look of how to convert between log and exponential form. So in general, b to the exponent x equals y. And then that would mean that log base b, y equals x. So this is a good way to show you that the value that you get from logging a function is actually your exponent, as you can see here. And that's a very useful tool, because what if we have some random numbers and it doesn't work out nicely? Your log will show you the decimal places, right? You can help you solve exponential equations. Okay, so let's convert this into our log form. So we would have log. We use our base, so our base value is 2 over here. And we know our y is whatever this is equal to, so 8. And we know our log always gives us our exponent, so it will be equal to 3. So there you go, you have your first answer. Let's take a look at b, so converting from log to exponential form. So we see that our base is 16. Our answer of our log always is our exponent, so we know it's 16 to the half. And so we equal our 4 over here. Okay, so that's how you convert between log and exponential form. Now what we're going to do is we're going to take a look at evaluating logs, and this will kind of help you understand what's the purpose of our log. Well, let's take a look at our first example. The first thing you want to try and do first is always just put in exponential form, because it might be easier, right? So if we take a look at this example, let's convert to exponential form. You get your base to the exponent x equals 32. Now, if you use a trial and error method, you know that 2 to the 5 will actually give you 32. So you can say right here that x is equal to 5, and so you've evaluated the log. Let's try out question B, because sometimes it doesn't work out this way, right? So let's see it. So we have our base 3x equals 50. Now, 3 to the exponent of nothing, like an integer in that sense, will give you 50. So we have to use the properties of logs to help us solve for this. So what we're going to do instead is we're just going to go log 50 over log 3 to get what is equal to x. So you can just plug that in your calculator. And when you plug that in your calculator, you'll get a few decimal places, so 3.56. And that is your x value, approximately, right? That's an approximate. Now, understand some calculators, you can put a base here, so you could just literally plug this in. But this is the way you do it if you only have the log button on your calculator and you can't change your base. So essentially, the purpose of logs is to find the exponent of a function. So thank you guys so much for watching. I hope you guys learned something new from this video. Peace out, Girl Scouts.